Now, when we have these molecules, they have to have a definite arrangement, true, but they don't have to be rigid. Like they don't have to just stay there as molecules. They can move, they can vibrate, they can like move, like they can twist and turn and vibrate and things like that, right? So it doesn't have to be very rigid. Now, what are the types of movements that you can have, right? So I'm discussing here 4. There might be more types of vibrations, but it's a good idea to appreciate the fact that, okay, molecules are not rigid. They have some kind of like motion in the molecules too. And these are the types of motions that will help us to identify these molecules in future. We'll see how with these varying forces that you have in the molecule, you can identify, you can pinpoint and identify what kinds of molecules are there, right? So in planetary sciences, for example, when you are trying to find out whether the atmosphere of Mars has a certain amount of carbon dioxide, or does it have nitrogen in it, or does it have oxygen, how do you do it? You're basically using this concept because we know that, okay, molecules, they are not rigid, they have vibrations in the molecules. The types of vibrations are different, there are different types of vibrations. And when you have different kinds of vibrations, they either, because of those vibrations, they can absorb certain amounts of energy and they can release certain amount of energies, because vibrations and all this movement requires energy, right? So there is a specific amount of energy that might be required by these molecules, and different molecules will have different requirements based on the type of structure the molecule has. Now, if we can identify the types of energies that the molecule is absorbing, we can say what kind of molecules are there, right? So this is extremely important. This becomes extremely important in planetary sciences and different kinds of identification processes when you want to identify the molecule based on their vibrations. And that is the reason I'm like bringing in this topic to you, that so that you know that, okay, it's not that they are static, they do vibrate among them, right? Okay, what are the different kinds of things that can happen? Okay, first, this is a molecule of some kind of organic molecules, some kind of carbon-based molecule. Now, what are these different things? So there are 4 bonds in carbon, right? Okay, so there are 4 bonds. We saw that carbon is in the 14th group, so it can have +4 or -4, basically 4 bonds to satisfy its octet, right? So therefore 4 bonds. So these are the 4 bonds. This is bond 1, 2, 3, and 4. I've just given them different colors so that we can differentiate between the different atoms. Now, I'm not specifically focusing on the atoms that are forming the compound in here. So this can be anything, right? So this can be hydrogen, or this can be like whatnot, oxygen, anything, okay? So let's not focus on that. Let's just focus on the type of movements that we can have in here. So what are the different forces that are actually happening in the molecule? What are the different kinds of stretching or movements or vibrations that are happening? Okay, let's look at a few very simple ones, okay? Now, there is a stretching that can go on, all right? So these 2 molecules, if you have this, so they can go and come back, and go and come back, and go. So it is stretching, right? It is doing a stretch, okay? What kind of stretch? It's a symmetrical stretch. Why? Because it could have done this, right? In one which is going more, and then other is going less, and they're not in sync. So symmetric along this line, right? Imagine if there was a mirror, these 2 would be the mirror images of each other, right? But what if they're not mirror images of each other? They're doing in a way that is not a mirror image. So that becomes an asymmetric stretching, and this becomes a symmetric stretching. So these 2 are basically stretching motions. Right in here, this 2, right? So these 2 are basically stretching motion. You don't have to remember, but just appreciate the fact that, okay, these are the things that could be happening inside the molecule. Okay, now what more can happen, right? Okay, this can do a motion like this in which these molecules can be doing this thing, right? So like if you have a scissor, you close the scissor, you open the scissor, right? So this motion is basically called scissoring, okay? Because the motion is like the motion of a scissor, okay? And in here, what can happen, it can have a motion of a rocking. It's like doing this, right? It's like rocking. So this thing can have a rocking motion, okay? So there can be various different types of motions associated with these molecules. There can be different kinds of vibrations, and it is these different kinds of vibrations that will help us identify them. How? Why? Because these different vibrations will have different energies associated with it, and when we have different energies associated with these, then you can, if you just identify the energies, you'll be able to identify the molecules or the type of vibrations, right? Sounds like a good idea, right? Like chemists were really smart, the people who were discovering these things, extremely smart. You see how small things, when you understand these small things, can lead to big discoveries, right? So you can just look at the atmosphere of any distant planet through your telescope, and if you can measure the different energies, you can identify the molecules in the atmosphere of that distant planet. Absolutely amazing concepts, right? I was astounded when I learned this, and these are the things that people generally talk about in a basic chemistry class like this. But I think this is a very simple concept, which at least people should know that, okay, these things happen, right? Okay, now we saw the concept of atoms, the concept of anions, how cations and anions. Now molecules can also gain charge. Like, so we saw how the elements like sodium, if it's lost an electron, can form an ion, right? So this is the ion that was generated from an element. You can have multiple groups of atoms in which there could be a collective charge on that. Like, you must have heard about this sulfate ion, right? So there is one sulfur atom inside and 4 oxygen atoms, and on that collective whole you have a -2 charge. Now we will study about where the charge is and how does it stay on one place and things like that, and how the stabler this molecule is, when you a negative charge or a positive charge on a molecule needs to be, if that negative charge is shared between everyone, it becomes more stable, and if it is concentrated on one atom of the ion and no one else is sharing that negative charge, it becomes destabilized and things like that. So the stability of the charge will also depend on what is the structure of these ions, right? So you can have negative charges like this. You can have, so this is the sulfate ion, this is the phosphate. You can have a nitrate. You can have a perchlorate, things like that. You can also have positive charges, right? So you saw you can have Na+. You can also have positive charges, like you can have a carbocation, we call it, the CH3+. So the plus charge is on the carbon, and so things like these. You can also have a negative, it becomes a carb anion, things like that. So not only can elements gain charge, you can also have groups of atoms called the molecules can also get charged, and we'll also call them ions, right? This is not a molecule, so this will be an ion, okay? All right, now the name cations and anions come from the use of electrochemistry, or this is just a tidbit that I have it and I'm just sharing it with you. So in electrochemistry, when you learn, so electrochemistry you must have heard about electrolysis. Like you have water and you electrolyze water, and water breaks up into hydrogen and oxygen in an electrolytical cell, right? So in an electrolytical cell, in which basically this is a realm of electrochemistry, electrochemistry deals with the exchange of electrical and chemical energy, right? So it can happen both ways. Like you can use electrical energy to do some chemical reactions, like you want to dissociate water into its constituents, hydrogen and oxygen. So water is stable, it won't do anything if you just keep it. So that reaction is not happening. So H2O will never give you H2 plus O2 on its own. So if you want to make that thing happen, you have to use some external energy. So if you're using electrical energy to do this chemical process, so that is electrochemistry, okay? So we have an electrolytic cell doing this. In an electrolytic cell, we have a positive, we have the positive and the negative electrodes, and we call the cathode and we call the anode, right? So the negative electrode is basically the cathode, and the positive electrode is called the anode. So this is how the name came by, right? So all those things that were moving closer and closer, the ions were attracted by the cathode sides, were called the cations. So cations, like cathode ions, right? And the ions we were migrating towards are getting attracted by the anode, the positive terminal, were called anions. So anode attracting ions, right? So which are the things that will be, what type of ions will be migrating towards the cathode? The positives, right? So the positives will be attracted towards the negative, right? So Na plus and other. In here, what's writing? H plus. In anions, what are the different anions? You can have OH minus, right? Cl minus, all the negatives, right? So these negatives are attracted by the anode, which is the positive, and that's why you call them the anions, right? Just a tidbit that came to my mind, right? Okay, so we have understood what a chemical compound is, right? What a molecule is. We'll discuss in detail what a chemical compound is and what are the forces. So there are many forces inside it. So there can be dipole forces, then can be van der Waals forces. These are different names based on the interaction between what type of bodies, what type of molecules, and what's the strength of those interactions. We have different kinds of stabilizing mechanisms, forces between those ions, forces between the parts of the molecules. And we will discuss those things in chemical compounds. But for now, I think we have a pretty decent idea about the molecules. Now, what are some of the examples? Now, I don't have to write the examples because you're smart people, right? But still, like H2O is a molecule, right? CO2, ammonia, and things like that. So these are made up of different atoms, right? Different atoms make up these discrete groupings of atoms, and they're bounded by specific forces, and they have a specific arrangement. You cannot have any kind of arrangement, like you cannot have hydrogen, water like this. This is not possible. This is not water. This is not water. You have to have water which looks like this. It has a bent shape. The shape is fixed. The distance between these are fixed, and we'll be discussing about these things in future when we'll be discussing with chemical bonds and the hybridization and how to actually find out the shape of the molecules and things like that. But for now, we have to understand that, okay, they're a discrete group of atoms, they have specific forces that are making them stable, and they have a definite arrangement, okay? And these, although they have a definite arrangement, these are not rigid.